part of our cycle of lectures. But before leaving the floor to him, let me just spend a few words on the School for Materialist Research. So the School of Materialist Research, SMR, is an education and research collective that offers intensive study courses, seminars, special programs, and research initiatives that address the materialism running through contemporary science, philosophy, art, mathematics, design, architecture, and politics. SMR was founded by the Center for Philosophical Technologies at Arizona State University, the Institute of Social Sciences and Humanities Skopje, and the Department for Architecture Theory and Philosophy of Techniques at TU Vienna, and the Critical Inquiry Lab at the Design Academy Eindhoven, and serves as a global hub for education, research, and experimentation at the intersection of the humanities, social sciences, creative fields, and the STEM sciences. So our guest tonight is Roberto Bottazzi. Roberto Bottazzi is an architect, researcher, and educator based in London. He has studied in Italy and Canada before moving to London. He is an associate professor at the Bartlett UCL, where he directs the MArch Urban Design. He is the author of Digital Architecture Beyond Computers, Fragments of a Cultural History of Computational Design, published with Bloomsbury in 2018, and editor of Walking Cities, London, published with Camberwell Press 2017 and Routledge 2020. Roberto's research analyzes the impact of digital technologies on architecture and urbanism, and is presented and exhibited internationally. So the title of this lecture, his lecture for tonight, is Omnia per Omnia, which is the Latin for anything by anything. And well, Roberto, the floor is yours.
Thank you very much, Riccardo, for the introduction, and thank you to Vera for the invitation for the lecture series, which I'm very much looking forward to. I should go ahead and share my screen, I suppose. Can you let me know if you can see the first slide? Yeah, thank you. Thanks. Also, I would like to say hi to some good friends that I saw are part of the meeting, and some of them will even present later in the series. So today, my presentation will be on Omnia per Omnia, a famous sentence that Francis Bacon said, and it will be the kind of the guiding one of the guiding principles through the presentation. So sorry, I'm just trying to. Okay, so as Riccardo mentioned a second ago, I'm basically an academic, a researcher, and I spent most of my time at the Bartlett, where I run the Master in Urban Design and write about the subject of digital architecture. Today, I would like to talk about the introduction of machine learning methods in architecture and the automation of the process of design. But rather than looking at it from, let's say, the point of view of the present, I would like to use history to look back at certain moment in history as kind of important precedents to perhaps offer another way to think about the introduction of advanced learning algorithms in architecture. I will, as a kind of quick route map through the lecture, I will look at the use of non-mimetic forms of representation between the end of the Middle Ages and the early Renaissance, particularly in regards to use of cryptographic methods, which I think are particularly fitting in a discussion about machine learning. Then I will talk about let's say the key of literally the key of cryptographic method, which are ciphers, and how ciphers handle the communication between random and intelligible messages. And eventually I will talk about perhaps the more contemporary condition and what we somehow whether we can establish a dialogue between these historical precedents and the contemporary condition. The images that will be part of the presentation in the second part of the presentation will all be about the work that the students of research cluster 14, the cluster I run inside the Master of Urban Design, have been working on for the past years. So this is basically, as you saw also in the previous slide, the introduction of data and automated form of analysis of data. It has become not only a very important societal issue, but even a very important urban issue, with a real transformation of cities and how they operate, and even a transformation of architecture through the distribution center as a new type of building that is basically a large physical computer, if you like, in the form of a large shed. To understand the speciality of these objects, it is perhaps not entirely necessary to look at the history of typologies in architecture, but actually it is perhaps more relevant to look at the history of computers themselves. So here we have an image of one of the early memories components built in the late 50s by Olivetti, and this is a precursor of RAM, rapid access memory. And this object is very interesting because it is not only visually but even operationally quite close to how a distribution center works. That is, RAM, rapid access memory, implies an object in which the time necessary to reach data stored in the object is equal, no matter what position the data is stored in. So we have a complete new model of space, one that does not have the traditional, let's say, coordinates or the traditional modes of thinking that architecture have, but at the same time, it's space and time that become bundled with each other to form a new type of spatial organization. And this is the kind of spatial organization that we are seeing affecting the design of cities and of distribution centers. So I think that, let's say, broadly speaking, the relationship between data and, let's say, our reality could be broadly categorized into three steps. The steps in which the map occurs as a reduction of the world, a selection of particular phenomena that are in our real life, and they are stored into a map. The birth of the search for perfect languages represent perhaps the point in which the system of representation and the phenomena that it has to represent are equal to one another. Of course, this has been the dream of the perfect language, such as the encyclopedia, but also is the famous story by Borges on the map that is as large as the territory that is supposed to map, to portray. And then finally, with machine learning, we begin to have a data environment and the possibilities with data which are in excess of what we have in our reality. So machine learning is more than reality. It is, of course, that kind of excess is also generated by the possibility by algorithm to generate new signs on the basis of data ones. And this is why I think we need to concentrate on cryptography, because cryptography is exactly the central column in this diagram. It's what controls basically the translation of signs between an unintelligible domain to intelligible one. It is obviously also one of the tenets of computation. Computation as an historical project has always dealt with cryptographic problems. And I think that for that reason, cryptography can offer an interesting way to think about the relationship between science and phenomena, but also between machine learning and design. So I'm going to talk a little bit, as I said, about the cryptographic methods. They emerge, let's say, the cryptographic methods that I would like to talk about emerge at the end of the medieval times with Ramon Llull. And with Llull, we have we have a very interesting moment in which the non-mimetic form of representations become central in the discussion. So this is why in Llull, cryptography is no longer contained to the field of diplomacy, to the necessity to share messages without being decrypted, but also becomes a system in itself to articulate knowledge about the cosmos, and particularly to articulate the signs and phenomena. Now, one thing that is important is that as we talk about machine learning and design, we have a general tendency to basically import, as designers, we have a general tendency to import knowledge from computer science and apply it to architecture. Of course, to a certain extent, this is very important. One has to have a certain degree of literacy of the tools that he or she employs. But I think what is equally interesting is to look at it the opposite direction. That is, to think about how architecture can articulate the domains of computation. So rather than a continuous search for efficiency or streamlining of operations, which is often one of the criteria through which algorithms are generated, we can also look at them the opposite way, through architecture, that is, through the ability to articulate knowledge through space and time. So this reversal, I suppose, is what led me to look at certain historical examples which emerge at the time in which the complexity of the world requires new tools to be articulated and described. So I did speak about Ramon Llull, and I want to just dwell a little bit on his method, which is, of course, has been discussed numerous times. But as I said, the cryptographic methods of Llull are not related to keeping secrets through because of diplomatic reasons, but they are actually aiming at decrypting the cosmos itself, and in fact to demonstrate the superiority of its creator, the Christian God. Nevertheless, the Llull system, as I said, uses signs in basically letters or numbers in forms of letters, actually, to compute and to generate particular kind of combinations that can be decrypted by using Llull's own tables. Now, what is interesting is that here signs and meanings are still linked to one another. There is a strong connection between the two. Of course, each letter can take different meanings, but the type of meanings it can take are predetermined before the combinatorial system is put into motion. And at the same time, this means that the number of combinations that Llull accepts in his tables is much shorter, much smaller than the number of combinations possible. This is, by the way, is one of the critiques that Leibniz made about Llull's work a couple of centuries later. But in short, from the point of view of design, Llull's system is not a search system, is not a system in which we try to experiment in order to look for new type of combination or different kind of combination. It is a system that is basically confirming, trying to confirm choices that had already been made. So for this reason, I think it's quite interesting to look at the system that Leon Battista Alberti developed more or less 1.5 centuries later. It's published in the Componenti Ciphers, 1466-1467, in which Alberti illustrates the first polyalphabetic cryptographic method, in which the number of ciphers gets multiplied and therefore varies throughout the process of encryption. Yeah, so the number of ciphers changes, and therefore we have a gap that opens up between signs and meanings. That is no longer, signs are no longer in a one-to-one relationship to meanings, but they are actually open to interpretation. What is important to point out is the role that mathematical thinking begins to have in Alberti's work, because the shift of the cipher as the process of encryption proceeds augments, exponentially grows the size of the space of all possible combination, making the exploration of this space only possible through mathematical means. The sheer size of the space of the ciphertext here acquires a complexity which exceeds human cognitive abilities and can only be explored through technology that prosthetically enhance human reasoning. Alberti methods used mathematical tools on language, marking the emergence of a notational system of signs which could be manipulated in abstract terms and potentially transferred to other domains, affecting what data could be selected, stored, and processed. In other words, Alberti notational method established a communication channel between strings of incomprehensible signals and intelligible one that precede the formation of meaning. That is, it was a system able to select an array of marks from the noisy reservoir of all possible constellations of marks. We therefore, in Alberti's case, we do have a cryptographic system that becomes a search system. At the same time, we also have, I think that is also interesting to, as we try to understand what kind of techniques and technologies can be developed to articulate the relationship between two domains, I think that it's also useful to briefly, very briefly, of course, to look at the birth of technical drawings, which, again, broadly speaking, takes place around this time. Of course, technical drawings emerge at the very moment in which the complexity of, or let's say the technical drawing for architects, emerge at the very moment in which the complexity of the building site is such that a new system needs to be developed in order to handle the complexity, but also to be able to become playful with it. So it is for these reasons that drawings begin to emerge. As I said, the techniques of drawings begin to emerge, and with drawings also we have interesting combination in which drawings, like as an analogy, let's say drawings like the machine learning algorithms we use today are machines that make machines. No, they are the technologies that also enable us to make other technologies similarly to the kind of algorithms we play today, and at the same time establish a certain mode of communication between bodily functions, particularly, of course, the use of the hand and the mind. Yeah. So again, I think this is an interesting conversation, or let's say element to keep in mind when we work with algorithm, that is not necessarily just technical, it's not just necessarily an intellectual activity, but it is a combination of the two. And drawings operate in that realm quite well. Also, drawings operate quite recursively in looping how, let's say, body and mind connect to one another. And finally, they become system for the circulation of knowledge. So this kind of hybrid knowledge now as a mean to circulate, that again is quite similar to how code operates. So I think it's interesting to think about what the introduction of technical drawings did to forms of representation, and also to the division of labor, because I think these transformation can have a certain echo with the current situation, in which we are also trying to work out what kind of relationship we can have between machine learning algorithms and design. So the technical drawings, of course, had an impact on labor, because this is the time in which the figure of the architect emerges, and the architect is precisely not a builder. The architect is not the person that physically assembles the building, but is the person that produces a number of signs that allow other professions to make buildings. There is, of course, a shift in knowledge, in the propagation of knowledge. So new technologies require the new means of controlling and communicating how different groups of people were working together. Again, the movement and the distribution of knowledge has a lot to do with the crafts and the formation of different professions, which takes us to the third point, which is learning. And of course, the 1563 is the date in which l'Accademia del Disegno is opened in Florence, basically the first school in which the art of drawing is systematically taught and transmitted. There's also an element that has to do with disciplinary divisions, so no longer craftsmanship, but also knowledge developed through science, mainly of course geometry, which, as I said before, is at the core of the birth of the figure of the architect and the engineer. And of course, there's a public element that has to do with technology becoming a cultural form of public interest. So the third moment in the Renaissance I want to briefly talk about is a further development in the use of code, in the use of basically notational systems to articulate signs and phenomena. And here I want to point the attention to Pico della Mirandola, whose work on combinatorial thinking is particularly interesting. Of course, in the Heptaptlus, which is the book from which this passage is taken, Pico begins to play with combinatorial logic. Of course, there's a whole Kabbalistic tradition behind it, but Pico plays with the combinatorial logic to invent new words, basically, and play with hidden meanings between the words. So we are here completely completely playing with the vertigo of ciphers and combinatorial systems in order to create a real searching mechanism that is no longer bound by pre-established hierarchies, that of course no longer sees man as passive component in the cosmos, but actually as an active element of it. And of course that is by playing this kind of, I called it vertigo, because it's also involving a certain element of risk of playing this with this kind of game and see what can be discovered. We know that, of course, Pico was eventually excommunicated. So, and that had a particularly deep impact in the second part, latter part of his life, where he had to return to Florence and defeated right after his meeting with the Pope. But this kind of operations, I think, are very interesting to play with the technologies in order to open up, to search new systems. And I also think that there's a part of the work of Pico that is interesting from, let's say, an ethical or even political point of view, because, of course, the idea of man no longer being a passive element of the cosmos, but an active one, has to do with an ethics, with being able to take responsibility for this new role that mankind had, and therefore being able to articulate that kind of role. So in Pico, often, of course, is the story of the man as a microcosm and a microcosm, as the element that can articulate these different scales together, and as such has the responsibility to be able to articulate these scales and keep them in some sort of relationship and equilibrium. So has to maintain some kind of order. So this is, of course, what Pico tasks to do when he wants to meet the Pope. The idea is to discuss the 900 Theses as a way to find a philosophical and a cultural way to bring peace in a moment in which peace was, many wars were happening from the Ottoman Empire coming from the east to Spain, but somehow the task was to culturally discuss a way in which peace could be brought to the table. And also the other thing is that, of course, the microcosm is often represented by depicting planets as humans. No? So I think that this is a very interesting element in which different scales and different kind of response, if you like, roles can merge into one another, in which the large and the small need to coexist in the body. And of course, the idea is that man, of course, can also contain all these different scale and has a possibility, as I said, to articulate it. I'm also saying all these things because most of the, especially today, there's often a kind of inclination to see in this period that is in the Renaissance, a period in which the anthropocentric view of man is celebrated, and of course, for many reasons now, I think we rightly don't necessarily like that view anymore. But I don't think it's a correct reading of the Renaissance. Yeah? As I'm trying to say here, especially with Pico, it's a lot more dynamic, if you like, dramatic and tragic moment in which these kind of scales and tensions are kept together. And it's very interesting that Pico decides to use code in the form of combinatorial logic to articulate these different tensions, and even to think about a way to venture beyond them. Sorry. So the as I repeated a number of times, of course, the fascination of cryptography is not so much with diplomacy, which remains, of course, the most popular domain in which cryptographic methods are applied. But subsequently, the experiments that we talked about, from Lulism to Pico, cryptographic method acquire a different role, in which they were understood to be able to unlock the book of nature, right? That is what takes us to Francis Bacon. And in Bacon, in fact, Bacon noted that by exploiting the power of ciphers, that is, these elements that articulate two different domains, it was perhaps even possible to reverse engineer the processes and create ciphers able to signify omnia per omnia, that is, anything with anything. That would have been the perfect cipher for Bacon. But what is interesting in his methods, I think, are a number of things. First is that technically, the biliteral cipher by Francis Bacon only uses two signs. Yeah, Bacon used the letter A and the letter B, but it could be any two signs. They don't have to even be letter. They could be two different sounds. They could be letters that are bold and letters that are written in normal font. So it could even be graphical. And that is important because, of course, we know now that the computer operates on two signals because all it really matters for the computer to work is difference. Yeah, is that one sign is not the other, and and of course that is I think technically very interesting from the work of Francis Bacon. So here cryptography expands, yeah, and as I said, deals with the natural domain, what there is basically, and becomes most importantly speculative, because by playing with this gap between the sign that represents and the phenomena that is represented, that gap allows the articulation of speculative speculative thinking. So computation can become a thought experiment, and I hope that that is a little bit what also came through as we moved from Lioule to Pico. The connection between the gap, let's say, between the two signs, of course, takes us all the way to language. And the connection between computation and language is provided by Saussure, when he stated that, and I quote, "Language may be content simply to contrast something to nothing." Saussure's observation that language is only constituted by negative facts also provides a useful analogy for the binary code, as zeros and ones do not represent anything other than their difference. For this reason, being discrete and distinguishable are the only two fundamental properties they must possess, exactly like in Bacon's example. Similar to language, difference is the necessary precondition for binary code to function. More directly, we can say that difference comes before the emergence of actual statements. The signs, therefore, the signs chosen to compute do not represent the empirical phenomena or a priori realities that would give it some sort of foundation. Similar to the opening remarks of Hegel's Science of Logic, the zeros and the ones of binary code represent the minimal semiotic articulation to differentiate something, one, from nothing, zero. Make it amenable to calculations while carrying no semantic value, or let's say not yet. Binary language simply represents pure difference in the most generic form, so that it can be later translated into more specific entities, such as numbers of letters. Hegel's description of his logical system could be interpreted as an illustration of discrete computation. Hegel says, with this, and of course he's referring to his own system, indeterminateness and vacuity of conception, it is indifferent whether this abstraction is called space, pure intuiting, or pure thinking. So what is a cipher? Let's now deal with what I said was, let's say, another segment of this lecture. So ciphers most commonly are understood as a rule-based mechanism to hide, encrypt, or reveal decrypt messages. But of course, the real interest is for the etymology of the word, which takes us much deeper into mathematics, as the word ciphers derives from the French chiffre, denoting the arithmetical sign of 4-0, which in turn descends from the Arabic cifra and the Hindu sunja, which means zero, empty, nothing. So a cipher is a particular element in a set, a code made up of letters or numbers that reorganizes all these items in that set. This definition matches Thomas Kuhn's second definition of the paradigm. Exactly matches it, by the way. Ciphers both belong to and organize the set of signs that they give rise to. Semiotically, ciphers are thus meta-signs with a double functions that give rise to a set that simultaneously they make intelligible. So before I go on, I want to, of course, reference both the work of Vera on this and Brian Rothman's on the cipher. And there are mixed quotations, let's say, from their work in what I've just read. But what I want to go on with is to say that this notion of paradigm is very, I think, very interesting to discuss ciphers, because paradigms from the point of view of logic are not a mechanism such as induction or deduction. That is, they do not move from the particular to the general, nor to the general from the general to the particular, but rather they move from the particular to the particular. And this is, I think, a very interesting observation in regards to the use of machine learning algorithms, which also operate in the same fashion. So here, I also, one more quote, one more reference, sorry. This time is Agamben's work on paradigms that partially inspires these observations. So the meta-semiotic nature of ciphers provides an instrument for both negotiating issues of translations and circulations of knowledge. More precisely, by being applied to random noisy strings called ciphertext, ciphers generate intelligible messages. And as such, ciphers are objects of design. That is, they can be designed, they can be calibrated, they can be playfully utilized, and so on and so forth. So somehow all the characteristic of a design object. So from now on, what you see is the work of RC14. But if we rewind it a little bit back to the observations on Bacon's ciphers, we can also see how ciphers acquire a speculative power. Rather than seeing them as functional devices to decode diplomatic secrets, they can be used as instruments to search an unstructured domain in order to provide intelligibility, patterns, and even order. Ciphers allow speculative thought experiments to be performed on the sets of signs by mobilizing them, combining them with other instances, or in other words, putting them to work. Ciphers' ability to articulate strings of signals derives from their semiotic status of empty signs. That is, the value of the ciphers does not reside in their semantics, but rather in their eminent ability to structure other signs. As meta-signs, ciphers enable the production of new signs emerging from newly established relationships. Such production is the result of a constructed act which operates both internally to the set, that is the cipher as an element of a set, and externally by restructuring any domain it is applied to. Contrary to the Platonic tradition, numbers are no longer entities to count real objects only. Through the introduction of the sign 0, numbers can also be used independently from real objects. That is, they become instrument for speculative reasoning. What Brian Rothman calls the move from proto numbers, that is number almost as ontological concept, to numbers. So in this third and final part of the lecture, I want to try to perhaps move closer to architecture and see whether the picture, let's say, painted makes any sense. So since the 1960s, architects have favorably looked at the development of design models based on systematic thinking, which emerged both in the field of cybernetics and linguistics. Such move was triggered as a response to the crisis of modernism, which by then was perceived as a sterile movement that has lost its innovative charge. The search for alternative models concentrated on procedural techniques that shifted the attention away from the formal solution in favor of approaches that granted design processes a more prominent status. Parallel to the research carried out by artists and semioticians, architects established indexical relationships between design processes and formal outcomes, in which traces of the former could be legible in the latter. Peter Eisenman is probably the most prominent architect foregrounding process in design at that time. His influence, however, extends to the first generation of digital architects in the 1990s who were still operating within the path of the American architect had traced. Though digital architects in the 1990s could take advantage of new techniques provided by advanced software, the formal outcomes were still largely legitimized by their ability to bear marks of the process that generated them. At the core of the debate was once again the persistent impossibility for architecture to regulate the relationship between science, meaning, and interpretation, an issue that is still current and that a cryptographic approach to digital design can provide new insights on. So the figure of the cipher can be of relevance in discussing digital techniques, as it offers a different model for articulating process and product, and moving away from both iconic type of computation that, for instance, characterizing analog computing machines, and indexical one characterizing procedural design. Contrary to indexical signs, ciphers, in fact, do not bear any direct marks of the object they are representing. In fact, they may not even be appropriate. It may not even be appropriate to speak of representation, as ciphers do not work mimetically, be it in an iconic or an indexical fashion. Rather, ciphers survey a given domain of data as meta-signs. That is, they restructure data to give it intelligibility, albeit partial. The relation between ciphers and data is mediated by mathematics, the language expressing both the behavior of the cipher and guaranteeing the incompleteness of the epistemological process initiated. Cipher generated new image of the domain surveyed. They open up new opportunities to speculate about space and its articulation. So in other words, ciphers become speculative instrument to articulate new possibilities for design. Lorenzo Magnani helps us grasp such new possibilities by emphasizing the abductive capacity of computational thinking. And I quote from Magnani, computational programs that execute various kinds of hypothetical reasoning can be seen as prosthetic abducers, just as microscopes are technologically created to extend human cognitive capacities and methods. Beyond strict end of quote. Beyond strict formalization and classical logic, ciphers open up new domains of research for computation to operate within dynamic, open, uncertain, fallible forms of rationality. For instance, hypothetical assertions such as those presupposed by abductive methods or fallible, paradoxical thinking as those proposed by new logic. Again, we are confronted with the extension of cognitive abilities that allow us to chart, learn, and eventually interact with unknown domains, such as those characterized by large data sets with so-called multidimensional data spaces. Computationally, we can draw an analogy between ciphers and algorithm based on their symbolic computation, their clear syntax based on mathematics, and the structuring, relational, and non-indexical quality derived from their meta sign qualities. Ciphers capture elements of randomness of an unknowable dimensions through computational operations. In designing in machine learning methods, the issue of instability does not have so much to do with the relationship between signs and meaning, rather more radically with the intelligibility of numerical and statistical representations of data generated by the application of learning algorithms to massive data sets. No longer bound by iconicity or indexicality, algorithms become speculative instruments to structure new relationships. And I quote now from Luciana Parisi, "Instrumentality is not a means to an end, but a method or a knowing how tending towards the determination of this or that result." End of quote. The challenge in applying machine learning algorithms to urban design is therefore consisting in, on the one hand, a representation of the urban complexity through data, and on the other, its re-articulation through automated algorithmic processes, which return intelligible and yet partial representations of it, amenable to further manipulations. Whereas the digital discourse in architecture has grown accustomed to thinking of processes either as a top-down or a bottom-up fashion, structuring spaces through data makes such categorizations irrelevant, as both conditions simultaneously can exist. So here we see play with different scales of granularity of data. For instance, classifying algorithms survey massive data sets with unprecedented granularity without the need of introducing any predetermined hierarchy of scale are a good example of what I'm describing. Likewise, the restructuring of geolocated data performed by clustering algorithms returns novel arrangement of scale, contiguity, similarity, discontinuity, distribution, which can no longer be accounted through can no longer be accounted for through parametric thinking. We can see how the introduction of machine learning methods in design does not concentrate anymore on the issue of form as a way to reconcile differences, but rather on the notion of relations, structure, transposition, interactivity, openness, incompleteness. In other words, the challenge presented by machine learning algorithm goes deeper than simply introducing new technique to affect more profound historical preoccupations of the discipline. In discussing the semiotics of photography, Roland Barthes proposed a relationship between analog and coded representation that is relevant for this discussion. Barthes spoke of photography, an analog medium, as a message without a code, as contrary to other media such as drawing, photographs promised a direct, unmediated image of reality. The decoding of a drawing, on the other hand, rested on the simultaneous presence of three elements which needed not to be there in the case of photography. These elements were the translation, the translation of the drawing implied the presence of, 1, a structure of rules that guided the process of transformation. 2, a gap between reality and its transformation. A drawing is a selective representation of an original scene or object. And 3, an operator that possessed an adequate level of literacy to successfully encode the message. This is a feature of all analog form of computations, which have a direct and almost visual type of computation, so much so that we can speak of pedagogical quality of analog computation. Barthes reinforces this reading of analog computation by extending it to all analog modes of representation. In the case of photography, the unprecedented level of realism afforded by the medium delivered an unmediated message, so much so that Barthes affirmed that photography did not represent reality by transforming it, as in the case of drawing, but simply by registering it. So design with machine learning algorithms implies an inversion of the paradigm introduced by photography that allows us to speak of codes without message. To stress the importance of code allows us to foreground the arbitrary nature of algorithmic operations. Data, similar to photography, is often understood to emerge from a process of registration rather than representation. However, data can only speak if encoded, that is, formatted in order to be parsed by algorithm, ciphers in our terminology, let's say, regulated by mathematical and semiotic qualities. Ciphers belong to notational code-based modes of representation. However, their meta-semiotic quality allow them to operate on data in ways that greatly differ from previous media. Meta-signs give rise to and makes sets of signs intelligible. That is, the design of the cipher determines both the rules of emergence and its projectability. How it will survey data, how it will structure it, and the relationships that it will establish between data themselves. Moreover, such rules of projectability are not static, and they change throughout the process of decryption, similarly somehow to Alberti's polyalphabetic cryptography. Though a great number of complex decisions are involved in the design of machine learning methods, we can speak of codes without message because ciphers still operate at the pre-semantic level, concentrating on relations or correlations, perhaps, that are not yet locked into specific meaning. So, yes, so on this issue of projectability, perhaps is worth spending a few more seconds by showing a little bit examples of the students' work in which we have all sorts of data sets projecting onto one another, going, let's say, from the environmental to the social, or to perhaps more personal kind of data sets, for instance, having to do with dietary habits. And and of course, these methods are eventually used to organize the city. That is, to operate with incredible granularity at large scale, operating with algorithms that can structure the city according to different ways of operating, and offer us humans, let's say, different insights on spatial organization. And these are somehow examples, let's say, of how students in the program deal with this kind of issues, dealing with all sorts of urban problems. Sorry. So I think that I'm concluding. Oops, this should be playing. I'm concluding my presentation here, perhaps simply returning a little bit to the main concepts that I wanted to illustrate. That is, what happens when we are confronted with an alien, not an alien. Yes, I think it's fair to call it an alien way of thinking. Yeah, we are confronted with the limits of our own cognitive abilities. How has architecture dealt in these moments? What kind of tools has it developed, and what kind of relevance have they had culturally? And do they offer any way to enrich the present conversation so that we don't solely concentrate on issue of efficiency or profit in using these methods in design? So I think that this is it, let's say, from me. So I shall perhaps stop sharing the screen. Thank you so much.
Thank you, Roberto. I would like to open the floor for questions. I will remind the audience that they can either raise a hand or also write in the chat, and also there's also the chat from the YouTube. So, are there any questions? Otherwise, I will perhaps abuse of my moderator position to start. So I was wondering, first of all, thanks for the very rich and well orchestrated talk, but I was wondering, so you talked about a lot about, especially concerning the architectural, let's say, development. You talked about the urban and the urban design, and I was wondering if you could find in this research you made a space or a room for what I would call the civic, so the space of the city in composition to the urban. So how would you relate this? And perhaps, I don't know if you could see this as a question that aligns with my first question. Is there, so because while you were speaking of Renaissance, you said that of course there was also a kind of a tragic character of Renaissance that is always often overlooked. And so what I was wondering is there also, like in the urban, is it for the urban more this kind of comedy and of play of scales as you were framing it? And so in that case, where would be the tragedy now? So I don't know if it was a graspable question. But...
Yeah, no, I think thanks, Ricardo. Yes, of course, the Renaissance tragedy is that we are dealing with a moment of high dynamism, which is often portrayed as a moment of lack of dynamism. So this is not a problem that we have now. I think that we are, I think, at least generally, or I suppose the kind of conversation I have seemed to all acknowledge the complexity of the city, the richness of the city, the contradictions of the cities are not somehow a battle worth fighting, because it is generally accepted, let's say, that the city is a complex, contradictory object full of comedies and tragic moments. So I think in that sense, perhaps it was more an argument to try to portray the Renaissance differently, let's say, and because it is different than the most, let's say, popular type of account we hear, it is a period that is much closer to us than we think. That is, I suppose, one part of what I can say on the question. The other part is that I don't know, Ricardo, if this is exactly answering your point, but what I find very interesting is this projectability, the possibility to really operate with data sets of completely different nature to one another. And in that, I think there's a lot more research to be done, but maybe in there is space for more, let's say, tragic representations of the city or tragic readings of the city, because it seems to me that the scope for connections of scales and types of topics that can be discussed is very fruitful, something that will eventually require some form of narrative as well, that somehow the mechanical operation of data crunching will not suffice to account. So I think in that part there's something that I find it super interesting, but I don't know whether we have actually I don't think we have got to the bottom of it, so to speak.
Thank you.
If I can continue there, all this is very interesting. Like Roberto, what if? So I'm struggling a little with all the students' work showing up like white noise, quite in contrast to your heroes from Renaissance. So, and therefore I'm asking with the role of the visual, you put very much emphasis on analog computing, on the visual, on photography, and put that in correlation to the cipher and the code and the digital. What is if the tragic is just that the visual is cut, we got blind, and the cipher is, this is what Alberti is doing with this disk, with this cipher disk, by setting two realities in a circular relation. He's cutting it. He got blind. What is your comment to that?
So, sorry, what was the last thing you said? What's my comment?
What your comment? How you would argue there? So I'm a little puzzled with the prominency of the visual in the work of the students, and I'm puzzled that if with the prominency of the visual, it tends to get white noise.
Okay.
And what is if the solution is just getting blind and start to talk?
No, yeah, it is true. It is true that the emphasis is quite visual in the work, and that also the way in which I used the images in this lecture, especially the second part, is almost like I shouldn't say, maybe the word is not perfect yet, but it's kind of background. No, I wasn't talking about the images most of the time. They were literally running as to set a certain mood. I mean, they have a certain kind of visual aspects. I don't know. I find them. I don't find them particularly. These ones I don't find them particularly visual, so to speak. Yeah, they're quite. I think quite basic in their or let's say they try to analyze data in a quite pure way. But I understand your point. I think that I'm not sure what to me what is interesting in this kind of work is it is actually still to try to make it to engage with the visual to some extent. Yeah, I think that that's a interesting part of it, which means having to do with also forms of exchange and communications with other disciplines. So yeah, I don't have more to say on that, but probably it's a question also that needs me to think about a bit longer. But thank you, Ludger.
Maybe to follow, or I don't know, of course, everything. So you're talking about the Omnia via Omnia. So everything is going to be related to the same issues, I guess. But what I was most interested in, because I never thought of it like that. You said ciphers can be designed. And there I wasn't sure whether you actually meant ciphers can be designed or whether ciphers in many ways are like objects that can be designed. Because one question that we were thinking about a lot when working at Ludger's chair with self-organized maps and so on is what do we call these sets of elements with which we are producing mappings and renderings and representations of patterns and relations? Are these sets of elements? I mean, it would kind of be easy to call them an alphabet, and in that sense, a cipher, I guess. But it never really sits right. for me, you know, because it's very limited. I mean, I liked a lot then the approach that one of our colleagues there, Miro Roman, introduced with the libraries. So to say, no, so because there are sets of elements with which we can, you said, search in uncharted domains,
Mm-hmm.
but it's not really uncharted domains, no? So it's more like libraries with pre-formatted contents. And the cipher that can search in them is kind of an atomism that is drawn or extracted out of the formalism that is already there. So to speak of of different libraries, making different libraries talk with each other through a kind of an intervention of an object or something like that. But how were you? Could you elaborate on this? How were you thinking of the cipher that can be designed?
Yes. Well, I use the word uncharted because of course I'm thinking of data related to cities. So in a way, it's not a book that it's different from a book, I suppose. Yeah, where the data in the book has already been pre-structured, if you like, by the author. In this particular case, when at least working with cities, which is where I spent my time, it is unstructured. It is uncharted. You are literally venturing out on a territory that has no clear coordinates yet. Yeah, as you know, I suppose if you want to go with the analogy, it is like it has a certain kind of forces. It has elements like when you sail, for instance. Yeah, you're not necessarily in a void or completely bereft of code or of element to orientate yourself, but it is a fundamentally uncharted territory. Then the part on the design, I speak of design because I think that it's about tuning these two domains, yeah. So that there is some sort of communication between them, and of course that communication can be of different value, right? That is not necessarily a closed process. Actually, that is when the process starts. But in that sense, I think to me that is sufficient to call that an act of design, because you can tune it like you design a musical instrument. Yeah.
That was my analogy now. No, so to say, it's like designing an instrument.
Yeah.
So, yeah. Okay.
So I think that is enough to say it's an act of design.
Yeah, clear.
Because also because I suppose like for an instrument, I can prepare a piano, right? It doesn't need to sound like any other piano, but it's still an instrument.
And then how does the notion of the scale relate to such design of instruments or objects or ciphers?
Yeah, the issue of scale is super interesting, and that is where I admit that I say always these things about no top down, not bottom up, but it's clearly too timid. Yeah, I think there has got to be a better way to articulate the in words what is interesting. But what is super interesting about scale is really the in very pragmatic terms, the possibility to operate on very large territories at incredibly high resolution. So the small and the large you never get one that needs to be subsumed under the other, but they can be kept together, operating simultaneously. So that's why I always like the planets drawn as humans, because they're kept together in obviously it's not an easy task to be kept together. But to answer your question, let's say pragmatically, it's really the fact that none of the two poles of the conversation, or in fact, none of the, from the small to the large and anything in between, none of them need to be ever subsumed or deleted or approximated. They can remain intact.
Mm-hmm.
And somehow, but there's not somehow, because of mathematics, they can be described, they can be changed, they can be affected.
Mm-hmm. Mm-hmm. Mm-hmm.
Yeah, but I hear your comment, because I don't think that to simply keep stating it as a negative, it's not, I don't think is enough to do service, let's say, to do justice.
Because the intriguing thing is somehow, no, that so with you, I mean, you drew it very drastically with the to make appear something before nothing, so that this negation. But the thing is that with code, negations like that themselves become positive objects. No, and then they don't live in the same space, and it's not a question of zooming in or out. You don't have the continuity of the scale, like in the powers of 10. You don't have that continuity. It's another kind of domain where I call this scalarity, instances of scalarities. No, they kind of tune together or not.
Yes, no, absolutely. It's not like the power of 10. You don't have to string it on a line to it. You can jump, or you can collapse everything together. Yeah.
Then subsequently, there's nothing like a granularity of data or something. So I'm struggling with that. So if what you're doing with AI and these maps is an instrument to play, this is without scale, and this is no granularity. You can play music, and it's quite different. The instrument is different from the music being played. And you can play music about emotional things, about your home, about love, about the city, about whatever. So, and therefore the instrument is without scale.
Yeah.
As data. So there can't be granularity of data, I would say.
I agree with that. I agree that the instrument is does not come with a scale label attached, nor does it come with the content that needs to be applied to. Yeah, that's why you can project it constantly, and you say you can apply it to a laughter or climate change. It's fine. It's true. So I perhaps should be more careful and say that when I speak of granularity, I speak of data applied to a spatial domain. So it's not well, these numbers, let's say, we are still dealing with numbers, I agree with you, but these numbers, some of them begin to be locked within a certain kind of space that is the space of cities or territories.
But this would be then the process of decoding, coming back home to reality. This is a kind of rendering of data to a certain reality, decoding. The data themselves don't do that.
No, I accept that when I speak of granularity, I already work within a certain spatial domain.
Yeah. I'm also struggling. You did it in the first part of your lecture with the drawing, and then you made no distinction between code and AI. So you said the drawing is like AI, and then a few sentences later as code. So me personally would agree with the code, because both of them play a certain instrument of their time to describe whatever there is in a specific mechanics, the actual world. AI is something else. I think this is a generic tool. because in principle, you don't do anything. So this is a general problem solver. It's quite different thing. Because you don't have to do things. It's doing it by itself.
Yeah, no, I understand.
Coding is an act of exploring, inventing, of projecting certain things. AI is not. AI is summing up, solving problems. Code is beyond problems. Like any mechanics is the trick. This is what you do with your language, what you do with the drama, with poetry, and so on. You just describe things the world never had been seen. This is mechanics. This is what I would say is the perspective drawing in the Renaissance, and this is what code is doing today, in contrast to what a program is doing. It's just an engineering task, solving problems. And therefore, I would say AI is a general problem solver. So there's something which just needs data to solve. Interestingly, you only need a single algorithm just to solve whatever you want. You just need data. And that's another category. And I would not say this is to put that the AI on the level of drawing, because you can't invent things with it. It's not a mechanics. And I think what is really wrong, I think you took these examples with k-means and assigned it what people are doing as AI. K-means is not AI. It's simple stochastics.
Yeah. I need to. I don't think I've ever used the word AI. I've used throughout the whole lecture. I think that I used the word machine learning and code. But okay. I never used AI. I think if I have, I apologize. But the machine learning, for me, I'm trying to keep it tight to basically the only thing I always talk about is dimensionality reduction algorithms, and I know that is, that is what is that? 0.5% of what. The conversation of AI is very, very small. And I know that there are many different types of algorithms that do dimensionality reduction. But to me, that is, let's say, within the format of a lecture, is a fairly neat example through which I can speak of the incompleteness of the cipher, and I can speak of the design of the cipher. So that is the but I agree with you that the AI is much broader. Yeah.
But I think the same. The cipher is always complete, but not correct. Whereas a signification is always correct, but never complete. This is what Girdle is saying, and this is a key problem in all computation. So, and therefore, machine learning is dealing around with these topics and puzzles which are so challenging the limits of correctness. But it never been complete, whereas code is complete by definition.
Yeah.
Cipher.
Well, the cipher, I mean, that we are, the way in which I use the word cipher is basically the algorithm that sets into connection two different domains. So the translation of one domain into the other domain is never complete. Yeah, is never something that is entirely translated into another language. I suppose I haven't thought this through, but I suppose it's not different when you translate from one human language to another human language. The translation is never quite complete, let's say.
I would say this question, because languages by definition are complete. Therefore, a translation is never correct.
Yeah,
This is the sharp thing. So, and if you put them, equal, this is algebra of things not comprehensible. This is algebra, and therefore it's not an algorithm what AI is doing. It's a generic algorithm, and it takes time, and it's never correct, but complete. And so I think that's a critical thing, especially if you say with Alberti, with a cipher, with a cipher disk, and so on. You have all these things that is there, super interesting, all your reference, your talk, but I think at this point I'm struggling a little.
Mm-hmm.
By the way, we also have a question from Katerina.
Hi, sorry, I'm not using my camera. I'm not quite presentable at the moment. I have a question both for the speaker and for Ludger. Okay, this is a form of a curriculum, let's say, this one in particular, but the overall curricula format of the SMR is such that we interact us from the humanities with those from the STEM sciences. So forgive me if, as somebody coming from the humanities, I ask a stupid question or I display my illiteracy regarding computation. But my question to both the speaker and Ludger is the following. Isn't the machine learning a process in which, in a way, we see something that does resemble coding? Okay, not the, not as, human coding it, in the sense of establishing the original code, etc., etc. But, that process that is figuratively called machine learning, isn't it in a way auto recoding of the code? So isn't it also code in a way? And if it is, even though it's less creative, I understand that part, isn't it nonetheless, technically speaking, coding still? Or am I misunderstanding something fundamentally?
Sure. Ludger, do you want to answer first or? No? Okay. In my, I'll take a step back. Maybe it wasn't incredibly clear. I talk about machine learning in general, but the real only example I give is on dimensionality reduction algorithms. Like Vera spoke about SOM or k-means or blah blah blah, all the rest, and that to me, maybe in my maybe my understanding is limited, but that is a form of coding. That's what I would understand as a form of coding. So I would hold the two together. Yeah. So for me, yes.
Okay, thanks.
Yeah, for me, it's the fundamental difference between code and program. So if we go with the Girdle Theorem, and this is what we learned to deal with quantum physics around 1900, with quantum physics, a group theory in mathematics, and so on, and what is basic of computing at all, is this theorem of Gödel, for example. It's a very iconic thing that nothing can be complete and correct. You're either correct or complete. So, and then I would say what we have with programs. So this is what 98% of computing today is done, because people like to do. because it's very pragmatic and easy to understand, because it just mimics and substitutes reality and what we understand. Programming is always correct. So it's a process of engineering within logic, a la Frege, Russell, and so on. And this for Neumann systems are that.
Okay.
They are with logic, with Frege, and they are always correct. The problem with that is that they're never complete. So this is what we are complaining about. There is an algebraic notion of computing, which is complementary to von Neumann, both established in 1930s. This is from Alonzo Church, the lambda calculus.
Yeah.
And this is an algebraic notion. So it has nothing to do with logic. It's an algebraic notion of computing. And I would say that's code.
Okay.
So on code is, as our speaking, always complete, but never correct. So machine learning is that you automatize with a huge amount of data, you automatize problem solving. And what we are always astonished about is that in a kind of fractal image, that the reality is very fine granular. So it's always surprising in detail. But code is beyond that. And I think this is what we had with the perspective drawing in architecture. This is what we had with the drama and the tragedy in our cultural history. Always with a kind of Renaissance. What we had with the Greek antiquity, what we had with Renaissance Baroque, and what I think we have with the 19th and 20th century. We just made these the 20th and 1900 since 1900. It's a kind of Renaissance that we are able to do unbelievable things beyond reality.
Okay, I understand.
Therefore,
Okay,
I
so
would
there
say
is-
it's machine learning. My hypothesis is it's quite, and I would say the impression what is there, that it's a huge bunch of different algorithms and so on. I simply don't believe that. It's a pragmatic problem that we have thousands of different algorithms, and I think AI is just the same thing like the differential of Descartes. It's just one thing.
Okay.
It's a very, very, very complicated to put realities in difference to establish rationality.
Yeah, sorry to ask this question. It might sound dumb, but yeah, I could never quite grasp what's going on there on that level. But I had an intuition that that's something like you're describing now. So in that case, machine learning is kind of a misnomer.
What is a misnomer?
A fake name, a wrong name.
Yeah, of course.
Naming.
Yeah.
Okay.
Not in principle, because learning, I think, is a question of engineering. It is didactics and so on. And so this is an 18th, 19th century conception. And if you do it by machines, it's quite proper, yeah.
Okay, I understand. Thanks a lot. Thanks.
Yeah, but I think some of these topics will be there also tomorrow in your lecture, Ludger. I take the chance to remind our audience that we also have a lecture tomorrow by Ludger Hoverstadt on circular genealogy of computing. So. Any more questions? I don't know how long we have, but I think if there are questions, we can go on.
I have another question where I would like to hear some more. And it's I was found it very interesting when you bring the paradigm into the constellation. No? So especially if we say that these impersonated stars, because they can I like this idea, no, that the different scales, none of them has to go. So there's a way to think the coexistence where we don't nivellate the hierarchies, but the hierarchies are also not fixed, kind of. And then to relate this to the paradigm, could you speak some more about this?
Yeah, so the paradigm, it's okay. I'm trying to think about how to give a relatively short answer, because the paradigm is really what is behind the book. No, that's what that's the thinking that was behind the construction of the book. But in regards to the lecture today, I think what is interesting was that is again this kind of, let's say, correct or incomplete or kind of conversation we have, in which we may be need to find different ways to articulate the relationships between things. Yeah, you spoke of scales. So instead of, let's say, inductive or deductive thinking, what I thought was quite interesting, and I think quite fitting with the notion of Cipher, is the notion of paradigm. Mm-hmm. Because paradigm is is a designated member of a set that all of a sudden can explain, not only explain other members of the set, but can form a set by becoming a paradigm, right? So it both generates and explains or provides some form of intelligibility of all the other elements. So I think in that sense that it has a particular to particular idea that is super. Yeah, I think it's quite interesting to think about how also the Cipher works, yeah, as a unit of data that can be remapped onto different kinds of data. So that to me is it was the fascination with the paradigm, and of course the paradigm as a certain value in architecture is never been really discussed properly by architects. There's a lot of misunderstanding about it, and somehow the best use of paradigms in architecture is still Foucault as a paradigmatic thinker that seems to know how to use them in architecture better than architects. So for that reason, I thought it had many reasons why it could become an interesting concept to articulate things, and as you said, to keep things into a relationship. But it was always a partial relationship of a particular to a particular, and that was perhaps, of all the reasons, the one that I thought was particularly resonated well, let's say, with the kind of issues I was trying to work around.
Mm-hmm. Mm-hmm. Yeah. And then there is with the paradigm the relation to Plato and the world.
Yeah.
Yeah.
Yeah. Yes, exactly.
Which would be interesting to pick up, and render or see how this kind of machine learning discourse.
Yeah.
So what is it learning precisely, if not the world? And if it's the world, how to think of this kind of engineering of it?
Yeah.
Yeah.
Yes, absolutely. No,
I like that very much.
That's exactly. There's that, and I think that also the Victor Goldschmidt's rereading of Plato's paradigms is very interesting. It had a very important role in trying to construct a much richer image for the paradigm, because, for instance, in Goldschmidt's you have element form, right? The paradigm is an element form, so it also brings together theoretical and practical, which is, by the way, how Foucault uses it as well. Yeah, the panopticon is both practical and theoretical figure. So those were very I think there are very rich ways to think about what we are dealing with. And in fact, I speak about the book because they may be also useful in understanding how to look at the history of things done with some computational machine of some sort, be it, let's say, the one we all use now or other types.
Mm-hmm. Mm-hmm. Yeah, absolutely. Thanks.
Good. I think, unless there are other questions or remarks, I think we can close it here. I would like to thank again Roberto Bottazzi for his lecture. And I hope to see you all again tomorrow, 6:30. And that's it.
Well, thank you. Thank you all. Thank you, Ricardo and Vera and Ludger for the hospitality and the questions. Thank you so much.
Thank you.
Very happy.
Roberto. Thank you.
Bye.